Well, hello everybody, and welcome to this presentation. In this presentation, we are going to go over some of the Common Core math and what does that mean in terms of math instruction and assessment. And we're also going to look at the NGSS and what that means in terms of science. Given the scope of this course, we're going to focus on just a couple of pieces here, but I'm going to give you resources that will let you delve deeper if you so wish. But again, given that this certification is pretty short, we're going to focus on a couple of things that are really, really important and overarching to this so you're equipped to support your teachers. And this slide you're probably going to see in multiple presentations. And what you're going to find in this class is we're kind of running two parallel lines. And these will intersect at different times, but especially initially, we're going to talk about them kind of individually, and they'll have pieces underneath them. Supervision of instruction will come in a later presentation. We'll focus on in the first couple of weeks, 2-3 weeks, and kind of math and science instructions will also focus on the first couple of weeks and unpack different components of that. For this presentation, we're going to unpack the Common Core State Standards for Math and the NGSS standards for science. So on the site, as well as the syllabus, and here again, are some links for you to get to the actual standards. This is part of your reading assignment for week 1. The expectation is not that you'll read through all the standards, but it's important that you go through and kind of browse through these so you understand what they look like. I'm going to share little pieces of them with you, but it's important that you're fairly familiar with the layout and where to find different components of these standards and how to interpret and read these standards. The top link is for your math standards. The following 2 links include connections to the NGSS standards. All right, so we're going to start by comparing the old standards to the new standards. And the reason I do this is other than teachers who very recently completed their credentialing, and even in that case, they may not be fully aware of the differences between old California state standards and Common Core and NGSS. And my experience has been, as I observe classrooms, much of the instruction I see is not aligned with the new standards. So I think it's important for us to get a sense of what the old standards demanded and what the new standards are asking for as a point of comparison. So as we look at, say, Algebra 1 here, which most students are probably taking somewhere between the 8th and 9th or 10th grades, you'll see these things laid out. And I think what's most important to see here is what they're asking for. So you can see that students are being asked to identify things, to solve equations, or to simplify expressions. But this is fairly rote in what it's asking. Kids are going to find things. They're going to solve problems that are already there for them. And this is kind of our old way of doing math. If we look at the same general area, we look at Algebra 1, or the equivalent of Algebra 1, you can see that with the new standards, when we talk about equations, kids aren't being asked to just solve or identify parts of equations. What they're asked to do is they're asked to create equations. To solve problems, they're asked to represent certain things through equations or graphically, and they're supposed to rearrange and move things around. So when we think about Bloom's taxonomy, we can really see that these standards are asking for quite a bit more, and the instructional approach is going to have to be different, where through previous standards, you can kind of do more drill and kill and get away with that in terms of meeting those standards. With these new standards, there's a much deeper level of thinking and doing on the part of the kids that is going to be required. If we move to the science standards, and I think these are laid out in kind of an even more obvious way, here are the old high school evolution standards, standard 8. And you can see that in each of these, it begins with students know. And again, this goes to show you that the old standards are really geared towards just knowing things and kind of memorizing things and identifying things and describing things. And if we shift over to the new standards, first you'll see that the layout is pretty radically different, but kids are being asked to do very different things. Communicating is part of the standards now, which again wasn't even really touched in the prior standards. They're supposed to build and construct things, they're supposed to apply, and they're supposed to evaluate. When we think of blooms, we see that these have shifted to higher levels of blooms. And again, this is going to require a different type of instruction. All right, so here are some really critical key takeaways when we compare old and new standards. And when you go into a classroom, the activities that we see should support this column on the right rather than this column on the left. So when we consider the old standards here on the left side, they're very much knowledge-based. What do you know? What can you kind of recite and identify and describe? When we consider how these old standards were tested, they're primarily tested through multiple choice, which again is, as we've kind of called it in the past, is multiple guess. It's a very closed-ended type of assessment and takes a very specialized kind of preparation and practice and is really quite limited. Where if we consider the new standards, both the Common Core and the NGSS, you can see that the new standards are much more based on practices and what kids can do and demonstrate as far as analysis and synthesis rather than simply identification or description. If you look at the Common Core tests or NGSS questions, you'll see that multiple choice has gone away. There are multiple response questions, and there are also performance tasks, and we'll look at one in just a second. And we find that the assessments are much more open-ended and much more focused on analysis as well as how information is delivered, especially in the NGSS. So here is an example of a question that compares the old math standards to the new standards, and I believe this is either 4th or 5th grade. And if you look on the left, here's the CST question, and you'll notice a few things about it. So Megan bought a package of 10 erasers. If 3 of the erasers are pink, what fraction of the number of erasers in the package is pink? So you'll see this is very much a definition question, and it's trying to see if I can understand what a fraction is, and I have my choices there, and I pick my choice and I move on. If you look at the new test, you'll find that it's quite different. So 5 friends ordered 3 large sandwiches, and we have 4 of these friends eating different proportions of sandwiches, and we want to know how much is left for Oscar. So you see that the type of thinking and the type of knowledge and the type of thinking that needs to be shown in this second question is quite different. Not only do you need to understand basic fractions, you need to be able to apply those and kind of reason your way through this problem by adding the different fractions and then subtracting whatever that might add up to from the 3 large sandwiches to find out what you have left for Oscar. And if you think about instruction, I can very much see on the left side where when we talk about fractions, you just say, you have a numerator and a denominator, you put one on top and one on the bottom, and you move on. It's something that could be taught quite easily kind of through drill and kill and just through rote memorization. Where on the right side, it's going to take a lot more than that to get a student to really understand how these fractions work and how they come together. So I hope that gives you a taste of how these things look differently. All right, so now I want to delve a little bit deeper into the Common Core. I'm sorry, into the NGSS. The Common Core is a little bit more straightforward, and with NGSS you have these cross-cutting ideas. They're a little bit more complex, and I'm going to give you a brief introduction of these. And again, an important thing to note is in the old standards, the standards very much led into curriculum. And in this case, it's critical that the NGSS isn't really curriculum. It's giving you frameworks, ideas, practices that kids are expected to do, but it is not curriculum per se. And as I said earlier, the most critical shift here is we're moving away from knowing to actually performing and doing. And when we look at these NGSS standards, they weave in together. There's no one component by itself. They all have to work together. Let's look at these kind of briefly as we finish up this presentation. So you will see that there are 3 different dimensions to the NGSS, and these work together. There are engineering practices, cross-cutting concepts, and disciplinary core ideas. The disciplinary core ideas you may think of as kind of aligned with the content from the prior standards, but the engineering practices and the cross-cutting concepts are quite different. So the cross-cutting concepts are things that you're going to continually see come back throughout in different grades and different subjects of science that are particularly important. So for example, number 1, patterns are really important in science. We see things like cycles over and over again. We see things like hierarchies over and over again. Very important concepts that are built into the things that kids are expected to do. And engineering practices are, how things are done. So for example, for number 1, asking questions and defining problems. So kids are expected to ask questions and define problems. And again, when we think of more traditional science approaches, very often we see teachers and curriculum giving the problems and giving the questions rather than positioning kids as scientists and having them ask questions and define problems. Here's kind of a graphic representation of how these things come together, and I'll show this in a little bit more detail in 1 second. But you'll see how at the top you have these practices. So in this particular example, we have a core idea that is part of Earth and space sciences. And the practice that's going to be part of that performance task is going to be asking questions and defining problems in earth science, and it's going to talk about energy. Where here we have life science dealing with patterns and conducting investigations. And at times you'll have multiples of these all connecting. All right, so let's talk about how we actually read these standards. And this is a little bit tricky and certainly something that as you start out, you may want to have conversations if you're doing science of asking your partner teacher to even show you how this works, to see if they know how this works, because it's certainly not nearly as simple as a list of standards as before. So let's go through these and see how they all connect. So at the very top here is the actual performance expectation. And notice this is not just what kids are expected to know, it's what kids are expected to do. And this is 3rd grade, life science 3-1. Analyze and interpret data to provide evidence that plants and animals have traits inherited from parents and are and that variation of these traits exists in a group of similar organisms. So kids are expected to analyze and interpret data and provide evidence. So they're asked to do quite a bit here. And the way the standard is really constructed is it's built off of these three kind of pillars here: science and engineering practice, the disciplinary core idea, and the cross-cutting concepts. All three of these exist here. As we start talking about tasks and how tasks are set up for kids, if all we see in a task is something that is a disciplinary core idea, we're really not meeting the requirements of NGSS. This is also true of Common Core, where if the practice standards are not included, not integrated into a task or a lesson, then we're not meeting the needs of the standards or what kids really ought to be doing. And as you'll see, this 3LS3-1 shows up over here as analyzing and interpreting data. That is going to be the practice. The disciplinary core idea is going to be inheritance of traits, and the cross-cutting concepts is going to be looking at patterns. Down at the bottom, you'll see connections to other standards that are also useful. So again, as we close this presentation, there are two really critical pieces that I want to make sure you're taking away. That when you look at a standard, both in science and in math, it's actually a composite of multiple things. With NGSS specifically, there needs to be some sort of a practice, a core idea, and a cross-cutting concept that's built into that. If they're not, we're not meeting the expectations of NGSS. The same is true of science. Let me try to give you an example. And there are a couple of other slides here that you can kind of quickly look at that will give you a little bit of additional detail. I want to look at a specific example, looking at a high school science standard. So here we go. So suppose I take this high school life science standard 4.4, which says conduct an explanation based on evidence for how natural selection leads to adaptation of populations. So you'll see that I highlighted three pieces here, and one of the things that you can look at, for example, is asking a question of, could the Zika virus get to California and under what circumstances? So here's kind of a guiding question, and the Zika virus has been in the news, and it's something that kids understand and is relevant to them in some degree, and it's kind of scary. So it's a guiding question, and the way a task could be set up is students are asked to create some sort of a presentation where you have to come up with some sort of a conclusion based on an analysis of data on climate change and mosquito adaptation. So climate change, I think, it's probably more than you would need in a basic task. And if this was a question, it probably would be done over multiple days. But let's focus on this piece over here on mosquito adaptation. So we know that mosquitoes like certain temperatures and they don't do well in cooler temperatures. So what might it take, or how would they get to California? And what might that mean, again, going back to the standards of natural selection? So here, kids would have to think about ideas like certain genes or traits that are more climate or temperature tolerant, and could the mosquitoes develop those, and how would they then succeed or fail reproductively in such a way that they're possibly in California or not, and what might they look like genetically, or what type of traits might they have, and how might they look differently, say, than mosquitoes in Brazil if they were to come to California, right? So again, this isn't necessarily a simple task, but one that hopefully illustrates where what we're asking kids to do here is construct an explanation based on evidence. So they would need to know some things about the mosquito and create some sort of evidence. They would have to understand the content piece, the core idea, which is this idea of adaptation, right? And in this case, it would be mosquitoes that have genes that are more temperature tolerant could survive, say, in California, where the ones that are not would not, because it would be too cold for them. So that would be connected there. And then there would be talk of patterns as far as potentially reproductive patterns and also patterns of distribution of specific genes. So hopefully this gives you a little bit of an idea again of how all three of these pieces need to be together in order for us to design a task, meet NGSS or the Common Core. And as you probably noticed, this is quite a bit more complex and more complicated than what was being asked before in the standards. It isn't to say that teachers haven't done this in the past, but it is to say that old standards did not require this. All right, so I want to go back to this slide as we close this presentation to kind of bring it all back together. And we haven't necessarily delved very deeply into Common Core and NGSS, but I think this would give you enough of a foundation that you can have a conversation with a teacher on a fairly basic level. If your teacher is kind of beyond this, then we'll have other videos that show you different places to meet them. But I think as a first step, it's really important that you know where your teachers are in terms of understanding what these standards are and what these standards expect. And do not be surprised at all, and do not expect that teachers know these and can maneuver through these quite easily. Most teachers that I've seen, even with the introduction and with PD, often don't quite understand these. So this is potentially a great entry point for you to have meaningful conversation that works as a springboard with your teachers. And again, the critical transition pieces here are you're moving from a knowledge-based kind of multiple choice, closed-ended type of environment to a much more practices-based, open-ended, kind of constructed response based on student ideas. When we talk about instruction, we'll talk more about that in a separate video. You'll see that the type of instruction that the first set, you could lecture to the old standards and your kids could do well. With these new standards, that simply will not work. So again, it requires quite a shift in teacher practice, and that's really going to be our goal for this this course is how can we help teachers move along as they kind of shift in practice. So I hope you found this helpful. Much more to come on this. Please do take a look at the standards and kind of familiarize yourself with them. You don't have to be an expert in every standard, but you should be able to read those standards, assess performance tasks to see if they meet these standards, and have some sort of a conversation with a teacher about them.